Hello everyone, I'm Songwoo Kim and today I'll be presenting our work titled All You Need Is Your Voice, Emotional Face Representation with Audio Perspective for Emotional Talking Face Generation. Let me start by introducing Emotional Talking Face Generation, or ETF for short. This task involves creating videos that keep the identity of the reference image while embedding emotional and audio information. Current ETF methods face a few challenges. First, they often produce emotions in the video that don't align with the audio, especially when there's no matching emotion label for the audio. Second, the emotion from the reference image influences the output, which can lead to unwanted facial expressions. Lastly, the emotional intensity tends to stay the same across frames, resulting in an unnatural look. To break this down a bit more, a face image consists of facial identity, expression, and emotional intensity. In an ideal scenario, these components are handled separately. However, in current methods, the emotion from the reference image gets encoded, which adds bias. Also, because the methods rely on emotional labels, they often fail to fully capture the emotional information from the audio. Finally, emotional intensity becomes uniform across all frames, which makes the output look unnatural. Consequently, this leads to the generation of undesired facial expressions with two conflicting sources of expression information. In the figure below, the red dotted line indicates this problematic scenario. Our paper addresses these issues by proposing solutions. First, we encode emotional information from the audio so that the video's emotion matches the audio. We also ensure that only the identity from the reference image is encoded. Lastly, we introduce a method to reflect different emotional intensities across frames, making the video feel more natural. One of our key techniques is audio to neutral translation, or ANT. This technique ensures a neutral face representation even when a highly expressive face is used as input. We achieve this by restricting the model's training to neutral faces during the pre-training phase and applying a metric loss to force neutralization. This helps to reduce the influence of emotional information from the reference image. Another technique is emotional representation from audio, or ERA. It uses two task branches to train the encoder to extract emotional information from the audio. The first branch is context emotion classification, which processes the emotional feature sequence using an LSTM to capture the context. The second branch is emotional intensity regression, which uses a pre-trained balanced arousal regression network and pseudo-labels to learn the emotional intensity from the audio. Our method performs well in both qualitative and quantitative results. The generated videos are of high quality and the lip movements closely match the ground truth. Our model also outperforms others on metrics measuring video quality and lip sync accuracy. When it comes to emotional representation, our model delivers the best results across various metrics for emotional intensity expression. It also shows the closest match to the ground truth in terms of frame-by-frame emotional intensity. Lastly, our user study results confirm that our model excels in lip synchronization, naturalness, and emotion accuracy, outperforming comparative models. Thank you for your all attention.